Okay, welcome to this lesson on index rules and their use in combined operations. So the four index rules we're looking at is the multiplication rule. So if you multiply two indices, 2 to the power of 3, multiply by 2 to the power of 2, or x in this case, x to the power of 2 plus 3, add the powers, x to the power of 5, because it's x multiplied by itself 5 times. Second one, for division, you would subtract a to the power of 7 minus 8 to the power of 2. So if it's division, we can subtract the powers. We went through this in the other video. 7 to the power of 0, anything to the power of 0 is 1, anything. And the last one, 2 to the power of 3 to the power of 2 is 2 to the power of 3 times 2. And that's 2 to the power of 6. So if you're confused on those, please watch the last videos. So we want to look at these in combined form. For instance, some of the more tricky questions, if we get something like, what happens if there's some numbers involved? 15p to the 12 multiplied by 5p to the 3, all divided by p to the 4. Let's put a number in there, 2p to the 4, just to make things awkward. How do we deal with them when they're combined together like this? Well, numbers will follow the way numbers normally work. So let's just work out the numbers on this top line. Let's keep the bottom line the same for the time being. So this is our first example. All right, so the number is 15 times 5. We can use a calculator for that to get 75. So we just do the numbers the same. But now we've 12, or p to the 12 multiplied by p to the 3. Let's go to our index rule. Multiplying, we add those two powers. So this will be p to the 12 plus 3, which is p to the 15. That's step 1 done. Step 2, if I can divide the numbers, I would. In this case, 2 does not divide evenly, so I don't need to. Or I can divide it in using a decimal. Maybe we'll use decimal, 37.5. And then I can have p. Now, this is a division, like rule 2. And you would subtract the powers if it's division of two power numbers with the same base. Same base here, p, so 15 take away 4 gives 11. That's our first example. Second example, we have something long like this, 27 a to the 9 multiplied by 9, b to the 5 multiplied by 2, a to the 6, all divided by 18, a to the 7 multiplied by, let's do 12, b to the 2. Okay, something like this. So combined operations once again. So take the top line separately to the bottom line. Let's do the top line first and let's put it down here. Now, if you want, you can multiply all these numbers out and then divide them by these numbers here. But there's some common things. If I'm multiplying by 27 on the bottom and dividing by 18 on the bottom, I can say that, well, 9 fits into that twice and 9 fits into that 3 times. So that makes that a little bit easier. And also, well, this is a 2 here, so 2 fits into that once and 2 fits into that once. So that's made my multiplication of the numbers easier. You don't have to do that, but it just makes it a little bit easier if I see something that divides in top and bottom. Okay, now let's multiply the numbers. 3, 9, and 1. So 3, 9, 1. That gives 27 on the top line, just numbers. What about the combined operations? So that's a to the power of 9. That's an a and a 9. That's not very clear. That's an a to the power of 9. That's a b to the power of 5 and a to the power of 6. Only the a's can be combined. The b to the power of 5 is a different base, so it cannot be combined. So a to the power of 9 and a to the power of 6. Multiplying rule, I would add 9 and 6 to get 15. b to the power of 5 is just b to the power of 5. So I'll leave it. If they're different letters or different numbers, we can just leave it and keep them separate. On the bottom line, the number 1 multiplied by 12 is just 12. And a to the 7 and b to the 2, they cannot be combined. They're two different letters. So it is what it is. But now I can do the division, and I can simplify further. Can I simplify 27 and 12 further? The numbers bit? Yes, I can. Well, 3 fits into 12 4 times. 3 fits into 27 9 times. So I've actually 9 over 4. And the numbers. See the way I'm dealing with the numbers separately, and then I'll deal with the exponents and powers afterwards. Alright, so now I just look a straight division of a's here. A to the 15, a to the 7. Rule 2 says I subtract that. So on the top line, which has more of them, a to the 8. B to the 5, subtract b to the 2, b to the 3. Can't do any more than that. That is my final answer. Let's do one more example. So if I had h to the power of 3 times, let's pick x to the power of 4 to the power of 3 times z to the power of 0. Okay. What would I do in this case? So this is our third example. This example, well, h to the power 3 is just h to the power 3, so it is what it is. X to the power 4 to the power 3, so this is from our fourth rule. If the power to a power, that multiply them powers. So that'd be x to the power 12. X to the power 12, multiply then, well, what's z to the power 0? Z to the power 0, anything to the power 0 would be 1. So that'd be multiplied by 1, but of course we don't need to multiply by 1, it just stays the same. That is 1, and that is my final answer. I cannot simplify it any further than that. The h's and the x's are two unknown numbers that we can't combine at the moment, so we just leave it with the letters in it. So remember the key things here. Deal with any numbers separately, so any large numbers separately, and simplify it using your fraction simplifying rules. And once you've done that, then use rule 1 and 2 to combine. If it's division, you subtract the little numbers. If it's multiplication, you add the little numbers. And the other rule then is this one. If it's a power to a power, you multiply. Okay, so try those. There won't be too many of these in the exams. There will be some of the easier ones, but this is new, so hopefully you can get the hang of it pretty soon.